Hello, I'm Wally Pratt and I'm the Director of Field Communication Protocols at the Fieldcom Group. And I'm the architect of the HART protocol for over 20 years. I want to thank you up front for joining me in this introduction to HART-IP security. I'm sure you'll find it interesting. In this introduction to HART-IP security, we'll review all of its features. We will start with a brief summary of HART-IP security and the defense in depth that's built into it. Then we'll lead into a summary of HART-IP itself, simply to provide context for the security discussion. This is followed then by a review of all the security features in HART-IP, and this includes communication security, audit logs, syslogs. And then we'll close by discussing how HART-IP security fits into an overall plant security lifecycle. HART-IP security overview. HART-IP security was designed to be relatively simple, but also scalable. Designed to support air-gapped networks because that's what you see in most process automation plants. Initial provisioning builds upon experience with wireless HART in that only a single set of parameters must be entered before you can securely deploy the device. Robust security is essential and layered defense was designed. Three major elements were included: communication security based upon TLS and DTLS, and audit logs and syslogs for detection and deterrence purposes. Field upgrades are mandatory. This allows for upgrades to new cyber suites and to address any vulnerabilities that might occur over time. Bear in mind, HART-IP is a tool and is designed to complement your overall plant security strategy. Now let's look at the defense in depth in more detail. Communication security, of course, is based upon TLS and DTLS, and the cyber suites we use are pre-shared keys and secure remote passwords. Those are used at the beginning of the security negotiation to establish trust. The actual encrypted communication uses AES 128, which, by the way, is the same thing wireless HART uses. To that, we added user credentials. These include a name, a key, and a password. The username could be for an individual or it could be based upon a role like a data historian or a plant asset management or something. In addition, we can identify certain users to be read-only. On the detection side, syslogging really provides a forced view of what's going on in the network. All the devices on the network post events to a syslog server. Audit logs is more of a leaf view because it's really centered on the device itself and provides summaries of what the various users have been doing. And so it's always available. We designed HART-IP to be simple to get started with a new device. The initial provisioning wanted to follow the same paradigms you see with HART devices or with wireless HART devices. Take it out of the box, connect it to client application. For that purposes, new devices have default IP addresses and host names, so you don't have to do anything special to get started. There's also default one-time security credentials you use for this initial connection, and you have to provision at least one set of user credentials, the ones that we call the security manager. From then, you can enter the tags for the device just like any other HART device you may have, and you can provision whatever else you want on the bench. But when you're done with this, it's ready to deploy the plant network. It's already secure communications, and you configure it with normal HART tools. Now let's look at a few details of HART-IP itself. Let's take a moment to talk about HART in more general terms first. HART's really about field communications. And we do support a number of different technologies, the original current loop, wireless HART, and HART-IP. But they all use the same application layer, the same tools. They use the same paradigm, so if you're used to using a current loop device, the kinds of things you go about to do it are the same no matter what the other ones are as well. And this commonality of paradigms and application layers are really central to what makes HART so powerful. HART-IP is a client-server architecture with session-oriented communications. Clients are typical applications you find in process automation, monitoring and optimization, process controllers, plant asset management, and what have you. The servers are essentially the process interface, and the servers are wireless HART gateways and remote I/O and HART-IP field devices. When we talk about session oriented, it means that the client has got to open a session and then all the communication occurs within that session. HART-IP puts a thin wrapper around the existing HART communication and then layers it on top of the internet protocol. As we'll see, there's a lot of advantages of working on top of the internet protocol, not the least of which is it'll work on any physical layer in the world. Ethernet APL is also very simple to accommodate, either via a native controller interface or via APL power switch over existing gigabit Ethernet. There's also a specific Wi-Fi based HART-IP adapter that allows access to stranded devices that is defined by the protocol. For device vendors, since it's the same application, it's pretty easy to pick up an existing IP stack and start doing HART-IP. For hosts, very straightforward. Many hosts permeate the HART data throughout their systems. And so with a simple different interface, the HART-IP data gets in there, and it is HART data, and then flows through the entire system. On this slide, we have pictured a simple HART-IP network. We have a HART-IP host application, a client, a field device, which is a server, and if it's an APL device, we'll have an APL power switch, and a lightweight set of network services. The field device, when it powers up, it will take and register its host name with the domain name services and get its IP address from DHCP. The host application knows the tag because the tag's on the PNID drawings and everywhere else. So it takes and looks up that tag in domain name services, gets the IP address, and makes the connection to the field device. Very simple operation with very little extra services. In fact, we run these network services on a Raspberry Pi in our test labs. The concept of tag is immersed in the process automation industry. It's everywhere. It's used in controllers, historians, there's tags and field devices. And when developing HART-IP, we decided to fully embrace the tag. As a result, we set the host name for the IP device to be the tag and registered it with domain names. Now, any of the process automation just uses the tag to connect to the field device. It's very logical. We do know that sometimes there are multiple process units that are identical, even down to the tags. So we have a separate data item called a process unit tag that if you enter it, it gets concatenated with the device tag, and that's what gets put into the domain name services. And so it all comes down to is if you know the tag, you can connect to the device and you're in business. Backward compatibility and interoperability are core principles of HART protocol. And as we improved HART-IP to make version 2, we followed those rules. That means version 1, version 2 clients will interoperate with version 1, version 2 servers. That's what we would expect. Security is essential, so version 2 servers will only communicate securely. That means that first time you connect to a new device will determine whether that device is going to continue to work always in version 1 mode or always in version 2 mode. If the client is a version 1, it'll operate as version 1. If that first client is version 2, it'll operate as version 2. This slide shows the startup sequence for beginning a HART-IP session. If you notice, the first exchange is called session initiate, and it's done the same whether it's a version 1 or a version 2 client and server. During this, we negotiate which version of the HART-IP protocol both sides are going to support. If both sides say they are a version 2 device, then we launch the standard TLS, DTLS security initialization, where we establish trust and exchange the keys that are going to be used for secure communication. From then on, all the communication is encrypted. Now we begin looking at the HART-IP security in more detail. First up is communication security. HART-IP communication security is based upon TLS and DTLS. HART-IP provides infrastructure to make that successful. That infrastructure includes things like user credentials and options like read-only users. We also identified a specific way to go about performing the initial security provisioning. And we also provide a factory reset in case you need a do-over if you've lost your security credentials or what have you. User credentials are used during the initial security negotiation to establish trust. By that we mean, do you really believe you're talking to who they say they are? HART-IP provides a minimum of 5 sets of user credentials. It consists of a user ID, options, and then the pre-shared key or the password. You can have one or both of those. The user ID can be a person or it can be a role. Pre-shared keys are 128 bits long. The password is case sensitive and uses ISO Latin 1 character set. We borrowed the concept of a security manager from Wireless Heart. The security manager is the first set of credentials in the list found in the field device, and only the security manager could change the user credentials. Security managers manage keys and create keys, make sure they're random, make sure the keys are kept secret, the credentials, tracks the credentials for users and which users have access to which devices. There are some relatively simple security managers already in existence. Every wireless HART gateway has got a security manager in it. The client that we use in testing and registering HART-IP products has got a security manager in it. So they can be pretty simple, but we do anticipate more sophisticated security managers will emerge over time. And that'll be driven really by what your needs are in the plants. One of the kind of cool things we added when we did communication security is the read-only option. This allows us to kind of follow that data diode metaphor where a particular user can only read things. I mean, there are request and response commands could go back and forth, or it could be publish subscribe, but no writes are allowed. You can't change the configuration. And of course, this worked not only with field devices, but the I/O systems gateway, because I/O systems and gateway know which commands are read commands from the HART protocol. So they can enforce it on the sub-devices, even if the sub-devices is a 4 to 20 milliamp device. One of the kind of tricky things about communication security is how do you get started? What are that first step? And we designed HART-IP so that you could work on a air-gapped network with just a device and just a client. It means there's nobody there can see what you're doing or look at the credentials that you're entering. In this case, the HART-IP field device is going to default to 192.168.0.42. That way you can connect to it. So that initial provisioning is you set the tag, you set the process unit tag if you need, you enter the user credentials, the PSK and SRPs, and now you're ready to deploy. And you've done it kind of bootstrapping yourself up that is in a very secure way. And this is a screenshot from the client that we use to test and register HART-IP devices. Specifically, this is a wizard we have built in there to do the initial provisioning we just talked about. You can see there are places for entering the initial security configuration and confirming that that's correct, changing the host name, which is the tag, and the process unit tag if you need be, and then also entering the configuration to talk to the syslog server if necessary. So this provisioning step can be a very simple wizard that walks you through it and allows you to get started with your HART-IP device. I'm sure nobody in the audience has ever forgotten their passwords. I have, so I'm, just a personal problem, I reckon. But in the discussions about HART-IP, we decided that we needed a way to have a do-over, a way to reset everything and get started all over again. And so there's a factory reset that's required to be supported by all HART-IP devices. This is essentially a hardware jumper or switch that has to be asserted when you cycle the power on the device. And so this will cause everything to be set back to the factory original conditions. Okay, this allows you to start over with your provisioning and get your device back online. And so this is an important element that allows you to recover in case something bad happens. Now let's talk about the first of our detection/deterrence strategies, audit logs. Audit logs focus on one leaf, a field device or an I/O within the network. They provide summaries of client interaction with that device. The audit logs consist of a header which summarizes the general health of the field device, and then a minimum of 128 records that summarize each session that has been connected to over time by clients. The audit logs are volatile, which means you lose them on power cycle, but that's all right. You know when somebody's power cycled it too. But the other really big benefit is they're always available. Even if the optional syslogger is not there, you still have diagnostics that you can figure out what's been going on. This is another screenshot showing audit logs. At the top you can see general information about the device, like when it was last powered up or when the security was last changed. Below that are a series of records for each client that talked to the device. What the client is, when it started, when it stopped talking. Particularly interesting is session status summary. That'll tell you things like whether or not that client changed the configuration of the device or whether or not that client was trying to hack the device. So pretty powerful stuff. Now we'll cover the second detection deterrent strategy we have, syslogs. Syslog is really a system-wide focus. This is really the forest view of what's going on in your plant. The way syslogs work is timestamp events are published from all the network devices. The syslog server is essentially a database that collects all the events, and it allows you to untangle things like plant trips or maybe a security event or any number of things. The concept of syslogging has been around since the 1980s, so it's very well established. To make it easy to search and sort HART-IP events, we follow the micro-focused common event format for our syslog messages. HART-IP specifies a diverse group of events that must be published by devices. These include things like when the server powers up, whenever somebody changes security credentials, whenever a session is opened or closed, whenever a configuration parameter is changed, and which configuration parameter in particular. All these are time stamped. If this is being performed by a client is triggering the event, then the IP address of that client is also included. And so these are a lot of different diagnostics that are published, and it allows you to kind of backtrack through what's going on. Now let's look how HART-IP security can complement and fit into the plant security lifecycle. This slide shows a typical plant security lifecycle, and we'll talk about HART-IP's role in each one of these. Procurement we're going to skip over because it's kind of out of scope, but we'll start with provisioning. Provisioning is about getting the user credentials securely and safely into the field device. Installation is your normal practices. You might consider an update to user credentials as an extra security step during that process. During operation, you're going to monitor the integrity of the devices. That includes configuration change counters, device status, maybe looking at the audit logs. Any anomalies you need to investigate during that time. Maintenance is usual plant practices. However, you must also consider whether firmware upgrades are going to be needed during that time because of security vulnerabilities or new cybersecurity suites. Replacement is sort of like going back and starting over with the provisioning and getting those credentials in there and then configuring the device. Disposal. During disposal, you need to evaluate your security exposure. Perhaps do a factory reset or maybe even destroy the non-volatile memory of the device because people do dumpster diving. And there are other best practices. Record and device configurations and changes, manage and protect your security credentials, access to the device, and so forth. Conclusions. At this point, you've gathered quite a bit of information about HART-IP security, and there's some key points you should take away from this. First, it's based upon industry standard TLS DTLS, very robust, very secure, relatively simple to deploy and do that initial provisioning. Contains elements of both prevention and detection, so we have a balance, this three-legged stool that we see here on the screen. Very compatible with air-gapped networks found in process automation. Don't need internet access to set up the security. Field upgrades are mandatory and available as the security threats evolve, so it's built for the long term. And it can play a very useful part in your overall cybersecurity strategy. Thank you for joining me today.